Okay, so hello everyone. My name is Karthik, GSEO co founder, and we are here today to interview Z. He is a second year student at Georgia Tech, concentrating in computer science with a prospective minor in mathematics. Among his accomplishments, Z has been actively involved in research, especially on surrogate modeling for urban regeneration. So, without further ado, let's learn more about him. So, Z, could you please introduce yourself?
Hello everyone. My name is Z, and it's like what Carter said. I'm a second year student at Georgia Tech, well, currently upcoming third year student. And it was when I came to Georgia Tech. Originally, I knew that I wanted to do CS and something related with math, right? But upon coming to Georgia Tech is when I get to like try out all these different um, I guess like specializations of what for CS. And there are a lot of different types of tracks here uh,
Mhm.
that people can major in. So, for instance, the one that I chose specifically was the machine learning and modeling and simulation tracks. And the research group that I was part of, surrogate modeling, happens to combine both of these aspects and apply it into different real world problems. So, to go into a bit of detail, um, the research group I'm in is known as the VIP group. Some of the other colleges also have this program, but essentially, you're part of this team of either a pre-existing project or it's a completely new project that you're starting. And students can break down into groups, and every single student has one entire goal, right? The main mission of our group is to do surrogate modeling or provide uh, insights or create tools for urban planners and designers to better help them make decisions in the future, because urban planning is one of those tasks where it takes many years of planning, a lot of budgeting, and it takes a lot of time as well to even accomplish some of these things and get approval. So we
True.
really want to make sure that whatever decision that we end up doing is efficient and also cost effective for these engineers. So that's what our group mainly does. And my team that was part of is the microclimates, where we focus on mainly just predicting as well as modeling these things known as microclimates or just localized weather climates for like a specific region. So the main effect that we're studying right now is the urban heated island effect. So we could take like the city of Atlanta, for example. It's very dense, super urbanized, a lot of different buildings, traffic, and you can expect that it gets very hot during specific times of the day as well as the period times of the year. And as the city continues to grow and become more industrialized, this effect is going to get even more severe if we don't look into how or do more research on the urban design and planning with
Yeah.
how the buildings will be set up in the future. So that's what our group focuses on, or my team focuses on, analyzing the microclimates and how the UHI or urban heat island effect would just progress. And we
Mhm.
started looking into different tools. There are a lot of different types of tools that engineers would use to just measure this thing. I think some of the most common ones were OpenFOAM and ANSYS, but
Okay.
which is also commonly used in like for other majors or like aerospace engineering, civil engineering, a lot of computational fluid dynamics essentially. But we decided to take a look at this tool that was recently developed by MIT. It's called the Urban Weather Generator, or
Yeah.
the UWG for short. And essentially, it's a tool which would tell us the microclimates of the specific location with that, and it allows us to set in specific parameters. So, for instance, we can put in the wind speed, the average building height, the density, and vegetation of that location, and it would spit out a energy plus weather file or EPW file that has all the. It's like a data set with all of these information of every single day of the year for that area. And so our main research is, how does this tool fare against the other ones that the current industry uses? It's fairly recent. It came out like a few years ago, but no one's really ever tackled it. There are like a few papers that looked at it, but no one really applied it into like real life scenarios. So we
Okay.
took this tool and decided to take a look at our Georgia Tech campus. So of course, Georgia Tech campus is still expanding right now. We have two new
Right.
locations, or two new, I guess, areas that they're currently developing right now. It's Science Square and Art Square, and we wanted to see, okay, well, why not just use the urban weather generator and try to see what the microclimates will be like for the these student areas, and then afterwards, to measure like how accurate this thing is, of course, we would need some sort of point of reference. So we're taking two weather stations on campus. So one is at the our campus recreational center, the other one near our football stadium. And these weather stations have been set up here for a few years now, and they basically just collect data of all the different necessary things that would tell us about like the microclimates there, wind speed, humidity, dry bulb temperature, all these important details. And through some uses of web scraping and Selenium, we're able to access the website with all these data, fetch some of the data from the website, put it into the data set on Python, and clean it out. And then that's how we get our EPW file. And using the
Mm.
EPW file, we'll be able to, we can input it into the UWG tool. And with the parameters, of course, the weather station also tells us like a few of those details as well. The average wind speed, okay, we can put that in. The building density, we can get that from our different faculty members, and vegetation of campus, we can also get that from faculty members as well. So with all these information, plugged it into the tool, and it starts simulating, and the tool spits out a new EPW file, which is a new data set that just contains all of the simulated data. And then afterwards, we will compare these two datas and just see how accurate it is. And from our results, we saw that like the average error was about 3.8 Celsius difference of the
Oh,
temperature.
wow.
So it's relatively good, but of course, compared to some of the other uh, more like used models within the industry, it's
Mm.
definitely less accurate. But the time it takes to compute these results are much faster because, according to my professor, he had previously used OpenFOAM for these types of modeling, and it would take upwards like 20 minutes to even simulate like a single block of
Right.
area. But with this thing, we're able to get it relatively down to like probably 1 or 2 minutes of simulation of
Oh,
like the
wow.
entire campus. So it's definitely much faster. But of course, the results could be tweaked. And another thing I would like to add on is that
Mm-hmm.
the tool is very complicated where it gives us the option to input over 53 different types of parameters,
Cool.
and so that's way too many. And some of these parameters we literally have no ways of getting data for, like
Mm.
urban boundary layer, like the vegetation albedo percentage. Like it's like these really like specific numbers. Like
Right.
there's just no effective way of getting data for them, or there's no like public access. So what I did and my team did is that we performed a sensitivity analysis. And for those who are unfamiliar with, the sensitivity analysis is just a method used to figure out which parameters or which variables are have the highest correlation to the output for a specific function. So we took a look at every single one of these parameters, and it gave us three different orders. So first order, second order, and total order. First order just says how important is this variable on its own, or parameter. Second order tells us if I were to change two things at once, how would it impact the total result? And then total order is how important every single one of these variables are together. And then through that, we narrowed it down to about 13 parameters from like 53. And these 13 are definitely a lot more realistic in terms of how we can get data for. So that was pretty much like the main journey from the last semester.
Wow. Wow, that's quite interesting. And honestly, such a big project as well. And as you mentioned, dropping down from 10 minutes to around 1 or 2 minutes, even though there's a slight change, there's a quite a big gap in time, which I think will be a
Yeah.
lot more used in the industry. It's a lot more efficient, it's a lot more time saving. So,
Mhm.
next question is, what do you think was the most important language that you use here? Was it Python? Was it machine learning? Was it Grasshopper? Which skill
Oh,
do you
yeah.
think played the biggest part?
I would say all of them actually.
Oh, wow.
Python, I still even use it like today because I'm still working on polishing up the paper for it to be published or submitted for publication. But
Mm.
Python is I've used it from the start and still use it right now. Super important. Without Python, we wouldn't have been able to get the data via web scraping. And the UWG tool actually runs on Python. Well, actually, there's another
Wow.
version of it that runs on MATLAB, but that was pretty outdated. So Python is the way to go, and Grasshopper actually allows you to make plugins, and
Hmm.
every single thing is also coded in Python. So there was a plugin of the UWG in Grasshopper that we imported because one of my team members, she specializes in architecture and she has a lot of experience with Grasshopper and Rhino 3D. And literally without Python, like none of this would have been possible. So definitely by far the most important language here.
Okay, okay. And you mentioned that you're working on it's a team project, right? So there
Yes.
will be multiple teams. The one that you're working with is microclimate. So could you just give us a rough estimate? How many members are there in the entire project?
The entire project, I would say, let me think. I think around 15 people in total. We have
Oh,
about
wow.
four teams, but
Okay.
that's 15 people, including our professor, and uh, we also have a master's student working with us. She's like hopping between teams and helping each
Okay.
one of us individually. But each
I
team would only have about like 3 to 4 people. My team in particular had three, including myself. So it's a very close space. Everyone knows each other, very intimate, and we spend a
see.
lot of time outside of classrooms working on it together as well.
Oh, wow. Wow, that's quite nice. And how did collaborating with, your peers and your mentors, how did it enhance the quality of your research, do you think?
Yes, 100%. So the main thing is that every single person in the team has different skill sets. I'm the more of the CS guy here. My colleague is an architecture major, and another one of my colleagues is civil engineering major, and she's had a lot of experience writing papers. So we take all these different skill sets and we kind of like just blend it together, and each of us focusing on what we do best, and that's how we really make sure that the tasks get done efficiently as well. Instead of having all of us like learn something completely new from the start,
Right,
and
right.
because I don't think we would have probably gotten this project done had we been in a team with interdisciplinary skills. So that was
Mm,
definitely a very important point, I would say.
I see. I see. That's quite nice to hear. And how do you see this project being used in the future? Do you want it to be used in the industry?
Uh, the industry would be nice because once again, this tool was originally developed by MIT, right? But
Okay.
no one really like looked at it. And I guess the main research for what we're doing right now is just promote it or see what are the possible applications of it, make it more mainstream, or see if it even is viable for mainstream engineering. And
Mm,
that's probably what I like to vision as well. And there's also a lot of more potential to this tool that could be developed or that could be added on to the original code. For instance, it does not account for things like mobility, traffic. It doesn't account for human psychology. Like for example, certain people go out at different times of the day due to different cultures. You
right.
have different events. Like for example, like July 4th, everyone's like shooting fireworks. That could impact the UHI effect very heavily
Right.
as well. And this tool doesn't account for all these things. But of course, right now we're talking very far into the future where we can even like develop a code for counting these things, but it's just like a future thinking. Like there's a
Mm,
lot more room for improvement and more room for increase in accuracy for this project. I would definitely say.
I see. I see. That's interesting. And while working on these projects, what skills have you gained that you think will help you in your future career?